So this is what we're always going to use in this course. Are these, by the way, are these the only possible scales? No. Like this one, for example, small. Is there nothing smaller than a pico? Or is there? There is. Does anyone know what's smaller than a pico? What's the 10 to the negative 15, basically? They always go down in threes. Anyone? Starts with F. Femto. Femto. Femto is the next one after pico. Does anyone know what's after femto? Atto. A-T-T-O. And honestly, I have yet to see anyone who cares about anything smaller than atto. Now we go to the big ones. What's the big one that you have here? Trillion, which is tera, which is what? 12 zeros. Okay, what's after a trillion? I think it's quintillion. So it's basically what? 15 zeros and so on. You are only gonna be really just look at these. I will never ask you a question on a test or a quiz where you go bigger than a what? Bigger than a tera or smaller than a what? Smaller than a pico. That's it. Okay. If you're interested in the other ones, just Wikipedia or Google. Okay. All right. So when a change of scale is needed, everyone, I'm gonna show you what probably will be a really good way, especially to do it with mental math. I always like to what? Play with the exponent. Play with the exponent using addition and potentially including negative numbers if you have small values until you create the exponent that you need. Okay, so what is the most important exponent rules in the following? Who remembers the exponent rules from grade 10/grade 11 math? Come on, exponent rules. You had so many. I think we learned 6 or 7 exponent rules. Tell me probably the first one that you learned. Nadim. Go ahead. The first one usually that they teach you when they teach the laws of exponents. Oh, okay, but what do you think was the first one that they actually had to teach you? Because technically everything else almost depends on it. Okay, the multiplication. Do you remember the rule? So are you talking about this one? Are you talking about this one? Not quite. That's almost like the fourth or the fifth one. There is one more fundamental before that. Yasmin? Yes, that's the one we're going to use. Thank you, everyone. The most basic one is this. Go ahead. B to the power of m times b to the power of n leads to what? M plus n or m plus m. Yes, thank you. This is how we're going to play with the exponents today. Okay. So, everyone, let's read the first question or the first example. The resonant frequency, has anyone heard of something called resonant frequency by any chance? How many people have heard of MRI? MRI. Do you know what it stands for? M for magnetic, I for imaging, I for what? For the word resonance. Resonance is something you study when you do what? When you do waves. If anyone here is going to major in electrical engineering or biomedical engineering, you will definitely study what? Resonance and resonant frequencies. Okay? So what they're saying, the resonance frequency of a certain chemical molecule is what? 5.43 times 10 to the 10. What's this? Hertz. Hertz measures what? Frequency. We're going to do a whole unit on waves, and Hertz will be the main vehicle we actually use to understand. Write it in what? G. What's a G from here, from the big scales? A G is a what? Is a giga, and a giga is a what? Is basically a billion. Okay, let's do it step by step. From the large scale sheet, the prefix, there's prefix and postfix. Prefix, because they always come before. Prefix for G stands for what? What's G? Giga. Go ahead, giga. G, I, G, A. Which is associated with which power? Just 9. Giga is always a 9. Okay. So what does this mean? Somehow we need to create a what? A what? A 9 in the exponent, in that exponent. Okay? We have to create a 9 in the exponent part, only in the exponent part of this value right here. Sorry. Okay. The easiest way to write the number is as follows. Give me 2 numbers that add up to 9. Obviously, there are so many choices, but we need to what? We need to use numbers that, sorry, my bad. Sorry. Give me 2 numbers that add up to 10 such that you're using this guy. There's only one choice, which is what? Now, you could write 9 plus 1 or what? I would encourage you to write 1 plus 9. Always write the number you want to create at the what? At the end, yes. So 10 is equal to what? 1 plus 9. So using the what? Using the exponent rules, we can say what? According to this one. But in reverse, instead of going this way, I'm going to go this way. 10 to the 10, because that's our power, is equal to what? Yes, 10 to the 1 plus 9. How do you split this one? How do you split an addition of exponents? What did it used to be? A multiplication of the bases. Addition of exponents is multiplication of the bases. So that means 10 to the 10 is, oh, sorry, the original number. My bad. The original number. Let's write the original number. What was the original number? Come on. 5.43 or 5.43 times 10 to the 10 is now what? 5.43 times 10 to the what? 1 plus 9. But I don't want to do it 1 plus 9. I'm going to split the bases. So what do? 10 to the 1 times 10 to the what? 10 to the 9. Which one of those do we have on the sheet? The 1 or the 9? The 9. The 10 to the 9 part, the 10 to the 9 part can be replaced with the letter what? That's the whole idea. I'm trying to create a what? A capital G. Which means now this becomes what? 5.43 times 10 to the 10 will equal 5.43 times 10 to the 1. And then all of this with the multiplication sign is what? Is G. Oh, sorry. Technically, G what? What's the unit? I forgot. Hertz. So everyone add a hertz here, which means you have to add a z, hz here. Okay. What's 10 to the 1? 10 to the 1 is like multiplying 10 by 1. So 10 to the 1 is just 10, which makes 5.43 times 10 to the 1 equals just what? 54.3. How can you write the whole thing on a single line? Just like this. 5.43 times 10 to the 10 hertz equals 5.43 times 10 to the 1 times 10 to the 9. 1 plus 9 is 10 hertz, which means 54.3 gigahertz. That's how we do it. Okay, yeah, go ahead. Sorry, say again. Do we have to do, you mean this one? Absolutely no. Nope. I am showing you how I split them, and I saw each one on its own. By the way, if you're a fan of this method, great. There's another method. Probably easier for some of you. Everyone, check this out. Who knows how to enter scientific notation on calculators? What button do I always use? I do not use the 10 times. I use what, according to mine? I use the EXP. Check this out. Everyone, listen up. What's the original value? 5.43 x. X. What does x mean? Times 10. X means times 10. It's always base 10. What's my value? 10. What scale do you want? Giga. What's the power of giga? Done. Just divide this by 1 x 9. That's it. Never fail. Guess what? That's technically unit conversion, right? I mean, can you think of the gigas and the megas as their own units? In a way, they are. I just don't like to think of them as units. To me, a unit is what? Kilogram, meters, second, watts, joules, Celsius. Those to me are scales. But guess what? You can always do that. Okay, Nadim, what if I wanted to convert it to kilos? The original one was 5.43 exponent 10. What if I wanted to convert it in or rewrite it in kilos? What's the power from the sheet for kilos? Kilos is always what? 3. So you divide this guy by 1 exponent 3. Oh, it's equal to 54 million, sorry, 300,000 kilohertz. By the way, is that technically correct? But is this a smart way of doing it? No. What is the closest power that we have in the sheet to 10? Exactly. Always go to the closest one. Always go to the closest smaller one. That's it. Okay? All right. Let's do this one now. Small scale. The diameter of a cell, roughly, is 4.25 times 10 to the what? -5. Write it in. Who remembers? Yeah, exactly. The Greek character is called what? Mu. Mu, like, did we use mu before in grade 11? In what? Coefficient of static and kinetic friction. Yes, mu is always the coefficient of any friction. When you use it, listen, when you use it as a unit, you call it what? Yeah, you never say mu meters. You have to say what? Micrometers. Micro is the scale name, micrometers. Okay, how can I do this the easy way? The easy way. The one I just showed you on the screen. With the what? Okay, I want you to use the mu. What's the scale for the mu from the small scale side? Negative what? -6. So all I'm going to do is divide this guy by -6. By 10 to the -6. Let's go. Clear? Yep. 4.52 or 25? 25. What's my exponent? Exponent 5 negative. Oh, my bad. Okay, hold on. 4.25 exponent 5 negative divided by what? 1 exponent 6 or 6 negative? 6 negative. Yep. 1 divided, exponent 6. Say again. Why 1? You have to write a 1. It needs, remember, scientific notation. Can you ever write scientific notation only using a power of 10? What always has to be at the first part of a scientific notation? What's the A value? What's the A value called? Coefficient. You need a coefficient. What's the easiest coefficient? 1. That one that doesn't change anything. Thank you. The radius of a cell is 42.5 micrometers. That's the easy way. Let's do it the hard way, because I really want to train this on what? Exponent laws. Okay? According to the small scale handouts, mu stands for what? Micro. Go ahead. Just write the word micro. Which is associated with what power or exponent? -6. What does that mean? We have to create a -6 here. We have to create a -6. But we already have a what? Tell me, how can you write -5 as an addition of two numbers? One of them is -6. -6 and plus. Yep, there you go. And which one we gonna write the last? The plus one or the -6? The -6, the one I want to use as a scale. So go ahead, -6 here and plus 1, which means we can write +1, -6, which is nothing but -5. All right, let's do it on one single line. Let's do it in one single line. 4.25 times 10 to the -5 meters equals 4.25 times, how many powers of 10 do I need now? 2, because I need to split them, just like I did here. Everyone, I'm doing this. I'm doing this step right now. 10 to the 1 times 10 to the what? Yeah, it's whatever this is. Still in meters. Still in meters. Equals. What would this be? 42.5. You got it. 42.5. And this part becomes what? Micro. And what do you still need? I don't know. I like to use this method because I can just do it in my head. Yes. Go ahead. All right, let's do just one more of the other side, and that's it. We're done. Okay, let me see the other side. Everyone, let's do part D, the wavelength of which light? Red light. Should we do it in steps or in one single line? Come on, one single line. What's my value? 6.95 times 10 to the. I want to write it in what? Nano. By the way, question. Can you write this in micro? No, you can't. Because -6 is bigger than -7. How many people? Okay, which number is bigger, 7 or 6? But which one is number is bigger, -7 or -6? -6. No, it's like temperature, right? Negative numbers higher are the warmer temperature. If I have -7, I cannot use any power bigger than that. So what can I use? -9 or negative what? Or negative? No, we don't. Everyone, we only use multiples of 3, just so you know. 3, 6, 9, 12, 15. You never use a numbers, but what? Multiples of 3. 3, 6. I can use only -9, -12, -15, and so on. Which one is the closest? -9. Give me two numbers that add up to -7, but they have a -9 in them. Only one choice. -9 and +2, or +2 and -9. So go ahead. 6.95 times 10 to the 2 times 10 to the -9 in meters still. Let me squeeze. Oops. Okay, what does this become? Come on. What does this part become? Come on. 695. And this part is the what? Just this part. Yep, that is actually the what? The wavelength of red light. Done. That's it.